We've spent some time looking at the RDS service and the traditional relational databases which are available to us in AWS. AWS also supports a wide variety of other types of databases. And so let's take a moment to look at some of the other database services which are available. The ElastiCache service is a distributed in-memory caching system. And it primarily serves as a cache layer in our application platforms, but ElastiCache can also act like a database as well, particularly when you're working with something like Redis, which is a commonly used key value store. If you recall back to the earlier part of this course where I talked about different distributed architecture patterns, caching is a pattern which we utilize to accelerate access to data, because accessing data when reading it from something like disk is relatively slow, and we can speed up the performance of our database queries if we were to just query the data in memory. And in this slide, I give you kind of an example of reading data from memory versus reading data from an SSD drive, where if you read data from memory, it happens on the order of 100 nanoseconds. If you read that data from an SSD drive, it's 150,000 nanoseconds. Orders of magnitude difference between the two. So anytime you can read data from memory, it's going to be significantly faster than reading it from disk. And ElastiCache allows you to store frequently accessed data in memory, and then you have the ability to quickly query that data in memory, thus accelerating the performance of your application. Well, where would you use this? Lots of common use cases. One is if you want to cache frequent database queries in your application. Maybe you have an application which stores a list of corporate store locations. Generally, your corporate store locations aren't changing on a minute-by-minute basis or even a daily basis. And so instead of storing that data in a database table and hitting that table over and over and over again on disk, you could store it in memory, and where it would be very frequently and quickly accessed. You might have web sessions. So you have customers who are hitting your website, and they're being given a session-based token once they authenticate and access your site. You might want to store that session information in something like ElastiCache, because many parts of your application may be referencing this token that the client is passing, and you want to be able to quickly look up those user credentials and do it using an in-memory based query, because it'll be just so much faster, and there'll be much less load placed on your database systems. The ElastiCache service supports two different types of caching systems. It supports both Memcached and Redis. Memcached has been around. Both have actually been around for a long time, but Memcached I think predates Redis, and it's been around a very long time. It's used as a key value store. It's very simple to use. Oftentimes we use it to cache database queries. So if we're making a common database query, and that database query will return a result set. Instead of hitting our database server, then the query then becomes sort of the key in Memcached, and the value becomes the result set that query would typically respond with. The Redis engine is more featureful than Memcached. I mean, it's a true key value database system, and you can store a wide variety of different data formats. It's more complex and more sophisticated than Memcached, and it offers more resiliency. Like you can deploy the Redis engine in a sort of master-slave sort of replication architecture. You can configure ElastiCache and Redis to support cross-availability zone redundancy. And so I tend to see Redis used a little bit more often today because of, because it is probably a more resilient sort of architecture that you can deploy. A couple of quick examples. Here's an example of using Redis, and we're using the Redis CLI, which is a command line based Redis client. The CLI is hitting the ElastiCache endpoint, and it's doing so over port 6379, which is the typical Redis port. And what it's simply doing is it's creating a new key. In this case, it's creating a key called A with a value, which is a string, and the value is just simply hello. And then the client, so it sets that value in Redis, and then it will retrieve that value by performing a get. It'll say get A, get the value for the key A, and Redis will return back with the value which is hello. Very, very simple. You're just simply creating keys, and you're setting a value for the key, and then you can go back later and retrieve the value that you had set. So Redis is providing a way to persist this data, and it's storing it in memory, so the retrieval is going to be super, super fast. And because it's key value, we're using, a hashed-based access algorithm, so it's going to be unbelievably fast in terms of the information retrieval rate. So that's an example of Redis. DynamoDB is another really popular database that is available within AWS. And we'll spend some time working with DynamoDB later in the course. But I just want to give you sort of a quick overview of what it's all about. Now, it's the AWS DynamoDB service is a NoSQL database, and it is essentially at its core a key value database, but it has what we call a document-based processing architecture. If you've used other document databases like MongoDB, then something like DynamoDB might feel fairly familiar to you. It's based on the Google Big Table design, which Google has its own database, its own Big Table database, which is very similar to DynamoDB. So this is an architecture which is well known in the marketplace. The DynamoDB has tables, but these tables are not like a traditional relational database table. That would be the wrong way to think of them. I would think of them more as being namespaces. And each DynamoDB table has a number of items that are stored within the table. And an item is represented by a JSON object, which we will also spend more time looking at in this course. But you could think of a JSON document as a JSON object as being a document that contains data. The big benefit of DynamoDB is that it's completely managed by AWS, and it supports an extremely high level of reads and writes. It has unlimited data storage. So unlike a relational database where you're deploying a database and you're specifying a certain amount of data that can be stored in that database system, DynamoDB doesn't have that same sort of limitation. You're not specifying how much data you want to store. You can just, keep putting data into the database, and it will automatically scale the amount of storage space for you. In fact, it can now automatically also scale the number of reads and writes. And so in many ways, it's like almost like a database service that you don't have to maintain or manage whatsoever. And you can sort of put it on autopilot and let AWS manage the configuration and the performance of the database for you. When you store data in DynamoDB, that data is replicated in 3 different data centers. Now, these might not necessarily be in separate AZs. Now, they're going to be in at least 2 different AZs. So you could have data across 3 different data centers and 2 different AZs. But the key here is that your data is going to be stored in multiple physical locations, so that if any one location were to fail, that you would still have access to your DynamoDB database. Here's an example of a document, of an item that you might find in a DynamoDB table. And don't get so caught up on the formatting of this, because we'll learn more about JSON documents later in the course. But the key here is just to see that there's sort of this hierarchical sort of representation of data, where there's, each data component is essentially sort of a key value, and you can create very complex documents using different key values and the hierarchy of and representation of your data. Redshift. Now, Redshift is a managed data warehousing and analytics database. It's what we call an OLAP-based database. OLAP databases are focused on analyzing and aggregating data. And OLAP stands for Online Analytical Processing, versus our traditional relational databases, which are OLTP-based. Those are Online Transactional Processing. And our OLTP databases are primarily focused on performing queries and getting results related to individual transactions. When might I use an OLAP database? When might I use Redshift? Well, I would use Redshift if I needed to perform some analytics across a large set of data. If I had to aggregate data together and to gain some meaningful information, to discover something interesting, then I would use a database like Redshift. Redshift uses a columnar-based storage format, which is different than our traditional relational databases. So relational databases are row-based, where each sort of set of data is stored as an individual row. You can think of each row as being like a transaction. Imagine if customers are ordering products, then each customer transaction appears as a separate row. In a columnar-based database like Redshift, then the data is actually stored in columns versus rows, which might seem a little bit funny at first. But imagine taking like a traditional relational database and pivoting the table so that our rows become columns. By storing the data in columns, it actually greatly can improve the performance of certain types of queries. And those types of queries are the OLAP queries, which are focusing on aggregation and aggregate sets of data. For example, if I wanted to sort of calculate the average price of a sales order across all of my sales in North America, that could be done much, much faster an OLAP system like Redshift versus a traditional database system that is querying data and having to select data based on rows versus columns. The Neptune database service is a managed graph database service. And we looked at graph databases a little bit earlier in this course. We would use graph databases to represent connections between different database objects. They're very useful for scenarios where you have to sort of model social media type interactions, where you have somebody who's a friend of a friend of a friend, or maybe you're creating some sort of recommendation engine where you are, based on other customers' purchases of similar items, you want to be able to recommend additional items that somebody should purchase. Or maybe you're trying to represent some sort of knowledge graph, and you have these sort of loosely connected sets of data that you want to be able to connect together. Now, you can represent social media relationships in a relational database. It can be very, very tricky, and the queries become complex and non-performant. Versus if you represent it in a graph database, that's basically storing the data in a representation that's closer to reality. In the way you query the data and model the data means that the response from the graph database engine should be much faster than a traditional relational database. The Elasticsearch database service is a managed Elastic service. And Elastic is essentially a search engine. And it allows you to store data and index data, and then finally search across massive amounts of data. And Elastic is a service which I see being used by many, many organizations today. Just in my area of the country here in the Twin Cities, we have a number of large national retailers, companies like Target and Best Buy and so on. And these companies make heavy, heavy use of Elastic. And it's used oftentimes for, a couple different reasons. One is just to search for information. So imagine you have a massive amount of products that you're storing, and you have description information about products, and you want to provide customers with a way to search your product catalog. Elasticsearch could easily fulfill that sort of role. And in some cases, I see Elasticsearch actually replacing traditional relational databases in some cases, just because the performance is so fast. The Elasticsearch service allows you to ingest data and then analyze that data. You can actually visualize data using a web console, which is called Kibana. We'll spend a little bit of time actually playing with Elasticsearch in this course. We'll set up what's called an ELK stack, so Elasticsearch, Logstash, and Kibana, which is used to ingest metrics and then generate some reporting based on those metrics. Now, you could spin up an Elastic server on your own. You can launch an EC2 instance or a cluster of instances and install the Elastic software on it and manage it. And there are many companies that do that. Or you can let AWS spin up the clusters and manage the clusters for you and update the software and keep them healthy. And the benefit of Elasticsearch is that not only is it a managed service, but it's also integrated with other services, as you'll see as the course goes on. It's integrated with AWS security. It's integrated with data ingestion services like the Firehose service and others. So there are a number of advantages to using Elasticsearch versus spinning up your own Elastic servers.